Hey, welcome back. We're starting with 7.3, the double and half angle, and that's the last part of Unit 7. This video is focusing on the double angle only, and then also within the double angle, I should be able to focus on the evaluate type of questions, and then the equations. And I'll make proofs. The third type would be proofs, and I'll make a separate video for that. All right, so here we begin. Now with double and half angle, the first thing is to do is be able to identify that it's a double angle equation or proof or evaluating type of question. Now you do have access to all these formulas, and here they are in this box. Sine double angle, like clearly you can see the angle has been doubled and hence the name double angle. It has the formula 2 sine theta cosine theta, whereas the cosine double angle has 3 formulas to pick from. And then the tangent to theta has the following formula. Now on the side, I can also show you how these formulas were derived. They're basically derived from the sum and difference formula, so I'll do that real quick with a couple of them. The sine a plus b formula, which you have utilized before, has this formula, cosine a, sine b. Now with the double angles, what we assume is that let's say angle A and B are equal to each other. And let's give them a third name. Let's call them both theta. Now angle A and B are both equal to theta. In that case, this formula turns into sine theta. And then I have sine 2 theta, because theta plus theta. And if you look at this side, it's nothing but a repetition of sine theta cosine theta plus another sine theta cosine theta, which makes it 2 sine theta cosine theta. And that kind of compresses and puts together the formula, which is what we have up there. So now you kind of know how it was derived. Same thing happens with tangent and cosine formulas as well. So if I were to use cosine a plus b formula, which states that it's the same as the product of cosine a cosine b minus the product of sine a sine b. But what if a and b were equal to each other? We can call them theta. This ends up being cosine theta minus sine theta, which makes this cosine squared theta, don't be squaring the angle, it's the value that has been squared, minus sine squared theta. And that gives us the first formula for cosine 2 theta. This is the first formula for cosine 2 theta, the first one right here. If I play around with this formula a little bit, cosine squared theta can be technically replaced with 1 minus sine squared theta based off of the Pythagorean identity. And then the minus sine squared theta, if I just carry it over, I have 1 minus 2 sine squared theta here. And that gives me the second formula for cosine 2 theta. So it's nothing but playing around a little bit. So that gives me the second one, and similarly get the third one. Similarly, tangent 2 formula was derived with tangent a plus b. So let me jump on to using these double and half angle formulas. Like I said, the first category is evaluating type of questions, followed by equations, followed by proofs. So let's jump into equations. This is technically example 1. All right, I've been given sine x is equal to negative 1/4. And at the same time, I've been told that this x value, the angle x, is in quadrant 3. Now, what's the question asking me? This question, for example, is asking me, hey, go find tangent of 2 theta. Let's say part B is not 2 theta because it's an x value, so I better stick to the same variable. Find or evaluate the value for tangent 2 theta, or find and evaluate the value for cosine 2x. Now, when I look at the first problem, please identify this is a double angle, twice of the angle. Hence, we have a formula for that. 1 minus tangent squared of that value. So if I were to use that formula, I need tangent x value in these parentheses. 1 minus tangent x value in these parentheses, and don't forget to square because that's what the formula says. So when I go look back at the question, I've been given the sine value for that x angle, not the tangent value. That's when I'll go in and create the triangle. This triangle is in quadrant 3, like I said, because that's pi and that's 3 pi over 2. So I carefully go ahead and finish it. Call it angle x. Sine is opposite over hypotenuse. Hence, I carefully use Pythagorean theorem, which will be 4 squared minus 1 squared. which is 16 minus 1, so root of 15. And then carefully I'm going to put a negative there because I'm in the third quadrant. Both x and y values will be negative. And once my triangle is complete, I can find tangent of x, which will be opposite over adjacent. So negative 1 over negative root 15. And I can totally drop the negatives. 2 negatives make a positive. And then carefully plug these values in here. Then comes in the math part of it. In the numerator, I have 2 over root 15. And the denominator, I have 1 minus 1 over 15. Because I'm going to go ahead and square both the 1 and the root 15. Then this simplifies to, I still have 2 root 15. And the denominator, that's basically 14 over 15. Right? And it's time to keep change, flip it. Keep change and flip. That simplifies to, this goes into it 7 times. And root 15 goes into 15 root 15 times. So that boils down to root 15 over 7. It's a tangent of twice of that angle, which we still don't know the angle, but we have been able to find its value, is root 15 over 7. Now I know I did take some shortcuts here when I was trying to simplify this part. 2 over root 15 times 15 over 14. I like to simplify and make the numbers smaller rather than make them bigger. So that's a 1. And 15 can be written as root 15 times root 15, and hence that one of the root 15s canceled out, leaving behind just that, in case you were wondering what happened there. So that's been taken care of. Let me switch to part B. This one's asking to find the value of cosine of 2 of x. Again, identify that's a double angle. Cosine comes with 3 different formulas. Sine, I actually have the triangle, so it really doesn't matter which formula I pick. But since sine value is given, I'm going to pick the one that had just the sine value, the third formula. Once the formula has been picked in, evaluate carefully. Sine x, the value of sine x has been squared. And it's time to drop in its value, which is negative 1/4. I'll do the math carefully. That will be 1 over 16. That's 1 minus 1/8, and that boils down to 7/8. Right, cosine of 2x. Similarly, they can also ask for sine of 2x, which also has a simple little formula. So those are the first type of questions, given partial information, asking you to evaluate. On the side, I'll give you another example here in the first category. What if this question was asking, let's say we had evaluate or find the value or solve cosine squared. Let's say we had 157.5 degrees minus sine squared of the same angle. Now you have to find the value of this without the use of a calculator. Well, it almost looks like we can't find that value, but if you look carefully, this resembles the formula cosine squared theta minus sine squared theta. Theta is the same, so I can use that. And that equals the formula for cosine 2 theta, which means I can compress it to cosine 2 of theta, which in this case is 157.5 degrees. When you actually double that angle, turns out to be 315. And 315 is a special right triangle. 315 sits right here in the fourth quadrant. Its reference angle is 45, so it's a 45, 45, 90 type, 1, 1, and root 2. Cosine of 315's value is root 2 over 2 positive. And we were able to evaluate the value of this expression using sum and difference. So that's the first type. Okay. I'm going to go ahead and move on to equations now, being able to solve equations. Here's my next example. I have to solve this equation, sine theta times cosine theta equals -1/2. So what am I trying to find here? I'm trying to find the theta value, which will make this equation true. Now to be able to find theta value, I'm going to try and use different things and see where that gets me. Keep in mind, that's the domain. It's good to know the domain, all the theta values that are between 0 and 2 pi, which is one complete rotation. We can start off by multiplying this equation by 2 on both sides. That boils down to -1. Now this happens to be the formula for sine 2 theta, if you have your formula chart handy. Okay, keeping that in mind, when I look at this, I'm like, sine of a certain angle is -1. And sine is -1 down here. Down here, coordinates are 0, -1. So sine is -1 down there, which is 3 pi over 2. So I'm like, 2 theta must equal 3 pi over 2 to make that possible. Now, just to make sure that I take care of all the answers within that domain, add 2 pi k to it. So we can generate multiple answers. Next, we are not looking to find the value of 2 theta. It's the theta, what we're trying to find. So divide by 2, divide by 2, divide by 2. 3 pi over 2 makes it 3 pi over 4 plus pi k. And just to make my computation easier, I'm going to make this 4 over 4, just so I can calculate easily. Pretty much that's the generic formula. The general formula is what we call it. And if we have the general formula, we can find as many answers as we want, depending on the domain that we are restricted to. So if I plug in 0 for k value, theta turns out to be 3 pi over 4, and that's well within the domain. Plug in 1 for k value, theta turns out to be 7 pi over 4, also well within the domain. When you plug in 2 for the k value, the next value would automatically be, keep adding 4 to the numerator, 11 pi over 4, and that's way over 2 pi, so we stop there. And in doing so, I have found both the possible answers. It's just time to put it together. So possible values of theta are 3 pi over 4 and 7 pi over 4. At some point in time, we might be even required to check if both the answers actually work, because we could have extra answers or erroneous answers. At some point in time, we'll do that as well. But for now, this equation is done. The 3 pi over 4, if plugged in here, will multiply to -1/2. And when 7 pi over 4 is plugged in for both of these and find the value, it will turn out to be -1/2. Actually, it doesn't hurt checking. So sine 3 pi over 4 times cosine of 3 pi over 4. Sine is √2 over 2, and cosine there is -√2 over 2, which makes it -2 over 4, which is -1/2, and sure, it works. Let's check the other one. Sine of 7 pi over 4 and cosine 7 pi over 4. Sine there is -√2 over 2. Cosine there is √2 over 2. So yeah, it works. 2 over 4, -1/2. Yeah, both work. Alrighty, moving on to the next example. Well, what does it look like after this? Here's another equation. I've been asked to solve it. Here's the given domain. And instead of theta, they're using x's. It doesn't matter. So carefully identify that we do have a double angle identity here. The rest of the equation is in sine terms. There's also a 3 sitting on the right-hand side. And the idea is to be able to find all the values of x. They should be angles. So the first thing I want to do is I want to use the formula for cosine 2 theta. So the double angle disappears and we get everything in terms of single angle. Now again, cosine 2 theta has 3 formulas to pick from. Which one will I pick? I'll pick the one that uses sine, just because the rest of the equation is in terms of sine. Once I do that, I'm going to copy the equation over. X equals 3, and it's time to start combining what we can. These two are like terms, and they put together make 6 sine squared x. There's a 1 sitting out here, plus sine x, and then subtract 3 from both sides, which brought everything to the same side. 1 and -3 can still be combined. -2 equals 0. And now that looks like a quadratic equation. Temporarily, you can replace sine x with y to make it look like algebra. So you can factor it out. Well, now I'm trying to find y, so next step would be to factor it out. A times c and b goes here, so that's 4 and -3. But there's also an a value, so remember you have to divide by the a value. That simplifies to 2/3. That simplifies to -1/2. So this gives me my factors, 3x plus 2, and the other one would be 2x minus 1. and I factored it out correctly. You can always check your factoring back, FOIL it to make sure that you did it correctly. I have accidentally switched the y to an x. Not that it's a deal breaker, but I did that in class too. Okay, well, 2x, 2y minus 1. All right. So from here, algebraically, what do? We can set this equal to 0, and you set this equal to 0, and find the y values. Negative 2/3, y equals half. And since we found y, it's time to bring back the trig part. So this is sine x equals negative 2/3, or sine x equals half. So now we're looking at what values of x. I'm going to do the right hand side first. We're looking for angles where sine has a value of half. So sine is half here at 30 degrees, or pi over 6. And then sine is half at 5 pi over 6. 5 pi over 6, those two. And if I keep adding 2 pi k to it, I'm going to get out of domain. This, on the other hand, is not a special right triangle. So to find x, to calculator type of question, we would have to plug in sine inverse of negative 2/3, and the calculator will give us a few answers. But don't worry about this part. Those two are calculator answers. You won't have this on the test or quizzes yet. Anyway, so there should be technically 4 answers, but we found 2 of them. The other 2 will be decimal answers. And I have carefully found out x. And we should kind of take these, plug it in here, no, one at a time. So plug it in here, work it out, and it should equal 3. Yeah, so we can test that at some other point in time. But keep that idea in mind that it might be required to check if the answers work or not. All right, so that was another example for equations. I'll do one more, and then I'll wrap up the video here. Okay, here's one more. Solve 2 cosine squared x minus 2 times cosine 2x. Please again identify, that's a double angle identity. You have a double angle here, you have a single angle here. We want to make sure we convert them all to single angles. That will be the first step, to convert it all to singular angles. So I'm going to copy the first one the way it is, minus 2, and then instead of 2x, cosine 2x, I'm going to use the formula, the cosine squared formula. The 3 to pick from, like I said, but I'm going to pick this one just because I want to keep everything in the same trig function. Carefully distribute from here, plus 2, and then subtract 1 also from both sides, bring it all together. These two combine to negative 2. Cosine squared x plus 1 equals 0. And again, from here, if you want to use algebra a little bit, call that y squared plus 1 equals 0. You're trying to find y. You subtract 1 from both sides. Then you would divide by 2 on both sides. Then you would square root both sides. So y turns out to be plus minus. Every time we square root, consider both the answers, both signs. And it's time to bring back trig. So it's cosine x equal to a positive square root of half and a negative square root of half. Now, square root of half is basically root 2 over 2. Like how? If you take that and split it up, that converts to 1 over root 2. When you rationalize it, we get root 2 over 2. So it's better to see this as that, just because that's on unit circle, or you can also create your triangles that way. So we're looking for cosine x equals root 2 over 2, or negative root 2 over 2. And I kind of showed you how that's equal to root 2 over 2 anyway. So from here, what angles support root 2 over 2 values for cosine? That would be pi over 4 and 7 pi over 4. And then from the other one, negative would be 3 pi over 4 and 5 pi over 4. Because root 2 over 2 are the 45s, so I knew that. Those are the 45s. Now this is pi over 4, that's 3 pi over 4, 5 pi over 4, and 7 pi over 4. And in quadrant 1 and 4, cosine has positive values, so that's why those two came from there. And in quadrant 2 and 3, cosine has negative values, that's why these two came from 2 and 3. right, I hope that made sense. Let's write it as in the correct format. So those are the 4 possible answers of x, which means when x is plugged in here and evaluated, left-hand side should end up equaling 1. Like I said, we'll check it at some other point of time. You are welcome to practice these 2 questions. That's an equation, and I've written the answers to both of them. If you arrive at those answers, then you've got a good hold of this. If not, feel free to ask me in class. I'll be happy to help as always. Alrighty, see you in the next video. Bye.